goes. So, independent events. So the reason conditional probability is so important and being able to calculate is so important is because of this. Every single regent asks this question on some open response. Are the two events independent? And that's all they're going to say. Or are they independent or not? They're not going to tell you what calculations you need to make on your own. You have to know what calculations to make in an independent situation, which brings me to my flashcards. Because I know you've missed them, so. There you have. I'm going to go ahead right now and guarantee you a flashcard quiz tomorrow. Does that sound like fun? Okay. It's been too long. It's so important. I know you don't want to have them, but studying them on a daily basis and knowing these like quick facts is critical. Because like on a problem like this, if it says determine whether or not they're independent, well, first of all, it kind of is like a yes or no question. But if you don't show the work and you don't know what work to even calculate to back it up, you're not going to get any credit whether you answer it correctly or not. So, this will be the front. No. Oh, my eraser is missing. The flashcard is going to say independent events. And events are only independent if the probability of one of them all by itself is equivalent to the probability of that same event given the restriction of the other thing. So whether that's red hair compared with red hair getting over a 90, right? If they are equal, then they are independent. If they are not equal, you say they are not independent. Here's a weird thing. If something is not independent, what would you assume it is? Dependent, but you cannot use that word. So, who cares what their reason is? It's a little bit silly in my opinion, but if they're not independent, you just leave it at that. Say they're either independent or they're not independent. Don't ever call it dependent, because dependent implies cause and effect, I think is their logic, versus just a correlation. And there is a difference, and we'll get more into that in stats. But when you are to answer these questions, you have to know that there are only two calculations that need to be made. The probability alone and the probability of that same thing given the other conditional. Don't go making 6 calculations, okay? There have been problems where people have made 9 different calculations and then just say these are independent events. We don't know that you really know what you're talking about if you're making 9 calculations. You only need 2. Now, the 2 calculations you'll see that Bella might choose to make might be different than the 2 calculations that Jack might choose to make, but there's different ways of making 2 calculations. Because this person, if you wanted to check the independence of events A and B, Bella could do this, and somebody else could do this. They could do B alone and compare it to B given A. So you have a choice, is what I'm saying. You don't have to all do the same thing alone. Bless you. You got Mike's paper over there? All right. So there's your definition up top, and we're going to show you how this plays out. So a survey of 57 6th graders was done to determine which subject was their favorite. The results are shown in the table below, sorted by gender. So essentially, just on the outskirts, I think what we're probably going to be trying to figure out is whether or not gender is independent from favorite subject. What do you think? Do you think your gender plays into your favorite subjects at all? Do you think gender plays into, like, the professions people go into? Well, favorite subject does have a correlation with the profession people go into. So I think that I think if you ask the average person on the street, they're going to say that males are more math science, and they're going to say that females are more English history. English, arts, artsy. That's just the general stereotype. Whether that's true or not, we'll see if this particular survey backs that up or not. So does it appear, based on the data in this table, that the preference for math as a favorite subject has dependence on students' gender? So they do specify math, right? They don't specify what gender we're going to compare this to. So, but you just pick. Are you going to deal with females or males? Pick right now. Let's all be on the same page. Females. So we're going to specifically check for females. This is where I'm saying you don't also have to check males. So let's look at the probability of, which one do you want to do alone? Math or female? Math. And so then we're going to have to compare that to the probability of what given what? Math given female. Whatever is alone has to come first, given female. So, take a minute. What's the probability that someone has a favorite subject of math? Overall probability, 18 out of 57 is correct. Good. And then do the other one. So the probability of math, in case you didn't know where Bella got that from, overall math number is 18 out of total population 57. And we're comparing that to, and what'd you get? 8 over 30. Did anybody do something different for math given female? So given that we're dealing with females, just look at your female row, which is 30, and then the both math and female, 8. Perfect. So compare those two numbers, and let's then discuss what happened to the probability of math. Did it go up or down when we were dealing with females? 18 out of 57 is 0.32. And 8 out of 30 is 0.27. So what did happen to the probability of math when we were looking just at females? It decreased. So if these are not equal, which they're not, that means, so just remember this, not equal means not independent. And leave it at that. I think we know mentally that that implies that there's probably some dependence. And that's kind of what I'm talking about. That is the stereotype, is that males are much more math-minded than females. Again, whether that's true or not, you'd have to survey the entire world to know that. I wonder what if you looked at SAT scores, the female average math score and the male average math score would be. I don't want to offend anybody, but I bet the males would be higher. There's a right brain, left brain thing there with gender that is pretty well accepted. I don't know if there's any studies that actually prove it, but okay. Like if you go to a college and there's engineering, if you look at all the engineering majors, it's going to be like 80% male. Correct. Absolutely, because there is a drive to try to even out that balance. Nursing. Do you think there's a correlation there with gender? I mean, there are certain jobs, not that there's not exceptions, there always are, but anyway, I think it does tie back to that. That's just so. That is what we chose to compare. Based on the way this was worded, we could have chosen, now don't do this because we only need to do 2 calculations, but just so you can see what the options were, we could have done math, and we could have compared it to math given male. And guess what? I'm pretty sure if this one went down, this one was probably going to go up to kind of counter that, right? Your probability of math was still going to be 0.32, but it was going to go up if it was math given male. That was an option. Now, we don't have to put math first. We could have put female first. Probability of female, and you could have compared it to the probability of a female given math. Or you could have put males first if you decided. We decided to go with female and just focus there, but you could have done Gender, they kind of left it open, so you could have picked either one. You could have done the probability of male, and you could have compared it to the probability of male given math. Okay? They'll all show different numbers, but they will also all not be equal. So your conclusion will be the same, not independent every single time. Yes? Any questions? Okay. Does it appear based on this data that the preference for social studies has dependence on gender? Okay, so they told us social studies, you pick the gender. Do you want to do females or males? Doesn't matter. Pick Olivia. Females again, sure. So, and then what two calculations are you going to make? What alone versus what given what? And we have lots of options here, so just pick one, Alexa. Perfect. So social studies alone, and she's comparing it to social studies given female. So social studies alone, what do you think about that, Faye? Perfect. And we're comparing that to, take a minute, see what you would put for that fraction for social studies given female before I call on Jack Taylor. Anybody get anything different for social studies given female? Chloe, what'd you say? 10 out of 30. Jack, where'd you get your 27 from? Right, okay, so it's out of female. So our female total is 30, and our social studies and female number is 10. So 10 out of 30 would be correct. So 19 out of 57 is 0.333. So there's a 33% that any person would love social studies versus a 33% that a female would love social studies, given if we were just looking at females. So these seem to be independent of each other, meaning it's equally likely to like social studies if you're a male or a female. Yes? So these are, because they are equal, they are independent. So gender doesn't seem to play a role at all in social studies preference, whereas it did with math. Good? Okie doke. That's it. We're gonna practice here. Okay. I sort of lied to you in the beginning of the chapter a little bit. We never did a question wrong. But I told you that and means multiplication. Okay? Do you remember this like day 1 or 2? I said if you look for the probability of something and something else, then you just find those probabilities individually and multiply them. That is true only if the events are independent. Now, if I go back to day 1 of the chapter, when we did do this, the probability of spinning a 1 and spinning a 3, we should all be able to agree that whatever happened on the first spin was completely independent of whatever happened on the second spin. That's why that worked, because spin 1's outcome was definitely independent from spin 2's outcome. Whatever happened on spin 1 didn't make anything else more or less likely to happen on spin 2. So they were independent. And again, here we were spinning twice independent. Later on in those notes, we do any other and? Yeah, we did. There was tossing a coin and then rolling a 6-sided die. So we were kind of looking at the probability of, like tossing a tails and then rolling a 3. We can all agree that whatever I flip, heads or tails, has no bearing at all on what I'm about to roll with a die, correct? That is, logically speaking, what independent means. They have nothing to do with each other. The outcome of one has nothing to do with the outcome of the other. We cannot say the same for hair color and eye color, right? The outcome of your hair color is somewhat tied to the outcome of your eye color. Agreed? And we know that just from logical day-to-day living by the age of 17, right? So just to clarify that definition, and this can be, if the numbers are presented to you properly, this can be another check for independence. Sometimes it might not, you might not have the numbers to do this given probability comparison, but you just know the individual probabilities, and you also know the and probability, and if these two multiply to equal that one, then that is another test for independence. So guess what? We have a second one. Probability of A and B equals the probability of A times the probability of B. If that's true, they are also independent. Okie doke? So there's two tests, and depending on the numbers that you're given, one of these is more conducive than the other. I will tell you from what I've seen, I don't know if it's just the way my mind works, but almost everyone I do that way. Truly. Unless I'm stuck and I can't figure out how to do it, I'm like, wait a minute, will this one work? So you'll see that here in a second. All right, so the probability that a person is left-handed is 12%. And the probability that they have brown eyes is 42. The probability that they have brown eyes and are left-handed is 2%. And maybe this all comes from my tendency to want to visually see things in a Venn diagram. Like, to me, there's two things floating around here: left-handedness and brown eyes. So the left-handed is 12%. So there's my x and y. X plus y equals 12. The probability that they have brown eyes is 42%. So y plus z has to equal 42 when I get there. And this is an easier Venn diagram because they're telling me the both. Probability that they have brown eyes and are left-handed, 2%. So y is 2%, which means, what's this? 40%. And what's the left? 10, because they have to add up to 12. Good. Is the event of having brown eyes independent of being left-handed? So if I'm going to do this the given probability way, I can do the probability of brown, and I'm comparing it to the probability of brown given left. Good? Take a minute and calculate those two probabilities from your Venn diagram, Haley. No, I just do because it just simplifies it for me. Angie, what did you have for the probability of brown? No. Tess, what'd you have? So, but you, like both of you you're doing the just brown. What is my percentage total in the brown circle? 42%. Okay? Also, you guys are treating 52 as the grand total population. That's not true. What about the people that are neither? Right? These are percentages, so they should add up to 100% of the people. So if that's 52 then we're missing 48 that are out here. So the probability of having brown eyes is 42. That doesn't mean, and this is a problem that I see come up, that does not mean brown only. And that doesn't mean just brown but not left. It means anything at all that's brown. That's 42 out of 100%. That's 42%. And what about the probability of brown given left? Chris Brooks, what'd you have for that? Okay, what is your left alone? No. Look at your left circle. 12. So that's out of 12. Whereas you're both brown and left. 2. That should be 2 over 12. Do you follow? So you need to be able to calculate these given probability things from charts. Like, it seems like you did pretty well on the homework with the train question. You also need to be able to do this from a Venn diagram. So brown overall is 42 out of 100. That's brown overall. And brown given left is your left circle as your denominator and your both circle as your numerator. So that's 0.42 versus, what's 2/12? Okay, so independent or not independent? Not independent. These are not equal, so not independent. Because if you had to describe this as in another sentence, the probability of having brown eyes went up or down if you were left-handed. Down. Interesting. I wonder what the correlation is there. All right, raise your hand if you're left-handed. Oh, you all have brown hair. Oh, no, blonde. Oh, okay. All right. So that's the one test. That's doing it this way. Now, if we were to do it this way and compare, what is the probability of left and brown? What is that number? Right in our Venn diagram. 2%. You could write 0.02 if you wanted. What is the probability of left alone? Not 12 times what is the probability of brown? Look at 42.42. So if you multiply those, 0.42 times 0.12, you get 0.05 equals 0.02. Again, not equal, so not independent. It can be done either way. But again, that given probability is much more common. Yes? In 4 and 5, just really quickly using that other one, if you want the probability of Q and R, you can just multiply the individual probabilities as long as they are independent events, and the preliminary information tells us that yes, assume that they are independent events. So on this one, they give you the probability of Q, they give you the probability of R, multiply them together, and that'll give you the Q and R. So that would be 1/8 times 2/5, which would be 0.05. On this one, just multiply them together, 0.8 times 0.2, and that gives you 0.16. But again, don't lose sight of the fact that the only reason we're allowed to do that multiplication to get there so easily is because they did tell us they were independent events. That property is only usable, that multiplication property is only usable if they're independent events. Good? We're fine. We've done plenty.